So before we begin, let's do a quick example. We have 3 times 13, and I want to use an area model to solve this. How do I do that? What's the first thing I do if I want to use an area model to solve 3 times 13? I guess I'll pick sticks because everybody should know this thing. Michaela, what's the first thing I do, the very first step to using an area model to solve this problem? I draw a big rectangle. What do I do next? Carla?
You break the rectangle into pieces. Into 2 pieces.
Good.
One piece big and one piece small.
Good. Where does my big piece go? On the right? On the left? Or on the right?
Left.
Left. Good. So my right piece is just a little smaller. Good. Now sometimes step 2 and 3 might get switched, but that's okay. Mason, what's my next step? So I've got my rectangle. I broke it into 2 pieces, a smaller piece for which place? The 1s or the 10s? And a bigger piece for the, good. So a small piece for the 1s, a big piece for the 10s. What do I do next, Mason? On which side? Left, right, top, bottom. On the left. So I take my smaller factor, which is 3, and I put it on the left side. Good. What's my next step? Aaron. Good. So I take the bigger factor and I put it in expanded form. What is 13 in expanded form, Aaron? 10 plus 3. And where do I write that? On top. I put the 10 for my 10's place above the larger piece. I put the 3 for my 1's place above the smaller piece. And then I put the plus sign above the split. What do I do next? Zari.
You take your number on the left and and the big piece on the top. No,
So I'm multiplying 10. My which place? Which place am I going to multiply next?
Your bigger number.
Which is what place? Can somebody help her out? Kingston.
10.
I'm going to multiply the 10s. So I'm going to take my smaller factor, multiply it by the number above the 10's place. Zari, what does that equal?
30.
30. What's the next step? So now I've solved my 10s. Cullen, what's the next step?
Multiply the 1s.
I multiply the 1s, which means I take the
Smaller factor.
The factor on the side.
And the factor on the top.
And the factor on top of the
1s.
Of the 1's place. And then I multiply them. 3 times 3 is what, Cullen?
9.
9. Victoria, am I done? What do I do next? So I add my, what place? To the 1's place. Now, do I have to do any regrouping here? Can you tell? You can tell right away. I'm not going to have to. Which means, do I have to set it up and down necessarily right now? No. So 30 plus 9 is what? 39. So that means, class, 3 times 13 is what?
39.
39. Okay, so today's lesson, we're basically going to be doing the same exact thing, just with no area models and with parentheses. So we're going to be doing today's lesson, the pencil and paper way. So we're going to be using expanded form. We're going to be doing this just without having to draw this extra model. So everybody, open your book to page 235. We're on page 235. And let's read the sentences under the title. What do you notice right away we're going to see in this little paragraph? What do you know we're going to have right away in this paragraph? Carla?
We're going to have a vocab word.
Good. We're going to have a vocab word. How did you know that, Carla?
Because I say a word highlighted in yellow.
Good. We have a bold word or term. Sometimes we have more than one. That is highlighted in yellow. So, Carla, what does that mean you need to do with this word?
That means we need to underline the definition.
And then what? Should today be the last time you ever look at it, Carla?
No.
No, because where will you most likely see this again, Carla?
We will most likely see this again on the math test.
Good. So, please read these sentences under the title Kingston, loud and slow. Who can help them out? What is that word? Distributive. Good. Distributive. Loud.
The distributive property can be used to multiply greater numbers. It combines addition and multiplication. First, the numbers are decomposed or broken down into parts. Then, the parts are multiplied separately and then added together.
Good. Who can tell me why I didn't have you stop and underline that very first sentence? The distributive property can be used to multiply greater amounts. Why do you think I didn't have you stop and underline that sentence? Michaela? Well, this isn't a word problem, though. Is this a word problem that we have to solve? No. But why did I not have you underline this sentence as the definition? This is not a word problem, so it has nothing to do with any of that. Is the distributive property can be used to multiply greater numbers a definition? Colin?
No.
No. Smith, what does that sentence tell us?
It tells us what it can be used for.
Good, but does that tell us what it actually is, Smith?
No.
No. It just because you know how to use something doesn't necessarily mean you know what it is. The next sentence, it combines addition and multiplication, helps us a little more, but is that the definition yet? Because does it tell us how to combine addition and multiplication? No. So we know the distributive property. We're not going to underline any of these first two sentences other than the word, but the last two sentences tell us exactly what it is and how to use it. So first, we decompose the factors. Then we multiply the parts separately. So we're doing this, just without this box. So do you think we're going to decompose our smaller factors or our larger factors today? Are we going to be decomposing our smaller factors or our larger factors today? Mason? Larger, just like we did here. I'm going to tell you one more time. We're going to do the exact same thing today as we did here, just with parentheses and things like that instead of a box. Okay, helper number 1, please sanitize, erase, sanitize. Okay, everybody, finger or pencil on example 1. If your pencil is on example 1, your hand should be on your pencil. Please don't make me say that every single day. It is not fun to repeat the same thing every single day because somebody is not listening or because they want me to have to do that. Okay, I'm waiting for everybody's finger or pencil to be on example 1. I'm waiting for everybody to be sitting up in their chair, on their bottoms, so that they are ready to follow along and not covering up pieces of the book. Okay, read in your head while I read out loud. Chef Cora hard-boils 6 dozen eggs each day to make egg salad for sandwiches at the food court. How many eggs does she hard boil each day? Well, there's our question. How many eggs does she hard boil each day? I'm always going to look after how many or how much or what is the number of first. In this case, I have eggs. So there's my answer unit. Now I see each day. So I have each, which tells me I'm going to multiply or divide. And then I see day, which is my other unit. Okay, now I need to reread the rest of the problem to see what the other important information is. Chef Cora hard boils 6 dozen eggs each day to make egg salad for sandwiches at the food court. Now, I see 6 dozen eggs. So now I have to figure out, what do they mean by that? Every day. That means in one day, she hard boils 6 dozen eggs. What does a dozen mean? What does a dozen mean? Zari.
It means 12.
It means 12. So if we're trying to figure out how many eggs she boils each day, and she hard boils 6 dozen eggs, what is our multiplication problem? Zadie, without looking.
6 times 12.
6 times 12, because we know that there are 6 of these dozen eggs. How many are in each dozen, Zadie?
12.
12. So to figure out the total, we have to take the 6 and multiply it by the 12 eggs in each dozen. Bless you, Colin. So our equation is 6 times 12. So now, if we imagine our array or our area model, I wish they would just do area models. We would have 12 would look like 10 plus 2, because we have a 1 in the tens place, which is worth 10. And we have a 2 in the ones place, which is worth 2. So if we have our array, we have 6 rows, because that's our smaller factor. And remember, our smaller factor goes on the side. And then we have 12 columns, but we broke it up. We broke it into 10 yellow columns and 2 green columns to show here's the 10s, here's the 1s. So what it looks like is 6 times 10 and 6 times 2. So without having to draw an array, that looks like 6 times 10 in parentheses plus 6 times 2 in parentheses. 6 times 10 represents the partial product for our 10s. 6 times 2 represents the partial product for our 1s. So does everybody see how distributive property is just using partial products? We're taking our larger factor, we're decomposing it or putting it in expanded form, and then we're multiplying our smaller factor by each one of those pieces. So that means 6 times 12 equals 6 times 10 in parentheses plus 6 times 2. What do parentheses tell us we have to do? What do parentheses tell us we have to do? Aaron? We have to do that first. So that means, can we add anything before we multiply? No, because both of our multiplication problems are in parentheses. So that means we have to do those first. So first, let's do 6 times 10. We have 2 sets of parentheses, so we can just start on the left and go to the right like we would normally do. Put that on your desk, please. So what is 6 times 10, class?
60.
60.
60. We're going to bring down the plus sign. And what is 6 times 2, class?
12.
12.
12. So now we have our partial products. We have the product for our tens, which is 60, and the products for our ones, which is 12. What do we know that we do once we find our partial products? Smith.
We add the two partial products together.
We add the partial products together. So Smith, what is 60 plus 12?
72.
72. We know that we don't have to set that up and down, because if we look at it, we're not going to have to do any regrouping. So class, that means Chef Cora hard boils how many eggs each day? Class?
72.
72
72
eggs each
eggs.
day.
Okay. Is everybody with me so far? So what we're doing, instead of doing this model, we're using parentheses to show how we found our two partial products. Instead of drawing a model and putting the answer in the box and then adding them, we're just using parentheses. We're breaking it down. We're breaking the larger factor down into its expanded form, and then multiplying the smaller factor by that piece each time. Let's look at another example. Helper number 1, please stand it. What is the first thing that we see on page 236? What is the very first thing we see on page 236? Zadie?
A key concept.
A key concept box. Anytime we see a key concept box, we know we need to do what with the information in that box? Victoria? Memorize it. Anytime you see a key concept box in this math book, it is telling you you will see this again. You need to memorize this information. So first, this key concept box tells us about what? Smith.
It tells us about the distributive property.
Good. It tells us about the distributive property. Usually these key concept boxes, tell us about something in words and symbols. Smith, in words, tell us what the distributive property is.
The distributive property says that you can multiply the addends of a number and then add the products.
Good. So addends are the pieces of what type of problem? Addends are the pieces of what type of problem? Michaela? An addition problem. So what that means is 6 times 12, if you break that into expanded form, 12 is 10 plus 2. We know the pieces we add together are called what, Michaela? The pieces that we add together are called what? Addends. So what they're saying is we can multiply the addends of a number and then add the products. So that means 6 times 12, if we're multiplying the addends, that means we're saying our smaller factor 6 times the addend for tens plus our smaller factor 6 times the addend in the ones place, which looks like 6 times 10 plus 6 times 2. So all we're doing is we're decomposing the larger factor into its expanded form and then multiplying the smaller factor by each piece of that expanded form. Is everybody with me so far? Okay, let's do another example. Helper number 1, please sanitize, erase, sanitize. Okay, everybody, finger, pencil on example 2. Everybody, finger or pencil on example 2. Please don't make me say it more than once. This is like the easiest thing to do. Okay, read in your head while I read out loud. 27 students are attending a performance at a children's theater. Each admission ticket is $5. What is the total cost for the 27 students? So there's our question. What is the total cost for the 27 students? Now we need to look at what information we have in our problem. I don't see how many, but I do see what is the total cost. What is the total cost? Which part of that is my answer unit? Zari.
Cost.
Cost. Now does that mean our answer is going to be blank cost, Zari?
No.
No, because a cost is my answer unit, but it means what?
Money.
Money, which means our answer unit, will it be the word money?
No, it's going to have a dollar sign.
It's going to be a dollar sign. Good. Then we have for the 27 students. Well, that is a number with a word after, a noun after it, but do we know if it's important just yet? Show me, don't tell me. No. So let's go back and read it again. 27 students are attending a performance at a children's theater. We see 27 students again. We're still not sure if that's important. Each admission ticket is $5. Well, we see each, which tells us to multiply or divide, and then we see admission ticket. So we know that has something to do with our other unit, but I haven't seen a number of admission tickets yet, so let's just keep that in mind. Then I see $5. Well, I know my answer unit has a dollar sign, so that means if I see a number with a dollar sign, that's important. But now I have to figure out this admission ticket thing. I don't see a number of admission tickets, but I do see a number of students. But if you're going to see a play, you are a person, but what do you need to get into the play? Mason? A ticket. So that means we're trying to find admission tickets, but if there's 27 students, that means how many admission tickets, Mason? Can the students get in without an admission ticket? So if there's 27 students, how many admission tickets is that? 27. So even though we see admission tickets, we know in this case each student needs an admission ticket. So that means 27 students is important. Because can those students get into the play without an admission ticket? No. So that means our problem, we're using a variable. C is going to represent the total. So we have to write the equation. Well, we know times $5 is part of it. What's the other part of our problem? We know times $5 is one part. What's the other part of this problem? What's the other factor? Without looking. Victoria? I can't hear you.
$27.
Is there anything that tells us 27 is the number of dollars? 27 students. Why is 27 students the factor when our other unit is supposed to be admission tickets? Why is 27 our other factor when our other unit is supposed to be admission tickets? Good. Because there's 27 students, each student will need one admission ticket, so that means this group needs 27 tickets to get in. Okay, so 27 times 5. Now we don't really know how to do that up and down yet. You may have an idea, but do you know 100% how to do it? You probably have an idea. Your idea may be right, but have you learned that lesson yet? So should you be doing it that way yet? Because even though you think you may know, do you 100% know? No. So we know we're trying to find 27 times $5. But we don't know how to do that. So first, we need to take 27 and put it in expanded form. What is 27 in expanded form? Zari.
20 plus 7.
20 plus 7. Which means 27 times 5, we know we're taking the addends of our expanded form and multiplying each of them by our smaller factor. So our problem becomes 20 times 5 in parentheses. What is 20? Which part of our problem, which place in our problem does 20 times 5 represent? Which place? Colin?
Tens.
The tens place. Good. And then we're going to add it to our smaller addend times our smaller factor. 7 times 5 represents which place? Carla?
1.
The ones. Good. And then we know we're going to add them together. Whenever we see parentheses, we know we do that first. If we have multiple sets of parentheses, we just go in order from left to right. So class, what is 20 times 5? Come on, guys. Basic facts and patterns.
100.
Thank you, Zari. Kingston had the answer too, but remember if I say class, that means you can call it out. Thank you, Zari. 20 times 5. Come on, guys. We're not going to go through basic facts and patterns every single time. You need to be able to do it. 2 times 5 is 10. There's 1 0 at the end of the factor, so we put 1 0 at the end of the product. 20 times 5 is 100. Okay, now we bring down our plus sign. And then we solve the ones. Class, 7 times 5 is what?
35.
35.
35. Which means our partial products. Our partial product for the tens is 100. Our partial product for the ones is 35. 100 plus 35 is what? Carla.
135.
135. Which means 27 times 5 is what, class?
135.
135.
We used a variable. So C equals what, class?
135.
135.
135, which means the total cost for 27 students is what? Zadie.
135.
Just 135?
No, $135.
$135. Okay. Is everybody with me? It's just a matter of following the steps. If you do not follow the steps, you're going to forget something and you're not going to get it right. Let's do this talk math. But we're going to cross out or an area model because we're getting past area models. You'll still see them on your test, of course, but we are moving on from area models when it comes to solving. So let's use the distributive property to solve 3 times 24. So you guys have a lot of space right here. Let's add example 3. And we're going to solve 3 times 24 equals. Zadie, first step is to figure out the expanded form of which factor? The every time, is it going to be 24?
No, the 10.
The tens? Kingston, can you help her out? The larger factor. So Zadie, what is the expanded form of 24?
20 plus 4.
20 plus 4. Okay, what do we do next? What do we need to do next? We just figured out the expanded form of our larger factor. Our larger factor in 3 times 24 is 24. The expanded form of 24 is 20 plus 4. What should we do next? Come on, guys, you're going to have to do this on your own in just a minute. Look at example 2. What did we do after we found the expanded form? Kingston, what do we multiply? I have a bunch of numbers here. I can't just multiply. I have to know what I have to multiply. The bigger number. What do you mean? I multiplied 24? Well, I thought I was trying to make this easier for myself.
You multiply 3 times 10 and then 3 times 4.
So I multiply the 10s and the 1s separately. I multiply my 10s and my 1s separately by what? The smaller factor, which means I need to do 3 times 20 and 3 times 4. What do I do after I multiply those two places? What do I do next? Carla?
You solve the 10.
Well, I'm not ready to solve because I haven't even finished my equation yet. What do I do once I solve these? Why am I solving these? Aaron, what do I have to do next? Well, let's wait a second because what do I have to do once I solve these? Parentheses doesn't tell me anything about what I have to do once I've solved these. Cullen?
Put a plus sign in.
Why am I putting a plus sign now? Why do I need to put a plus sign between these two multiplication problems? Why do I need to put a plus sign between these two small multiplication problems? Zari?
So you know you're going to be adding your answers that you get in the multiplication problems, and then you add them, and then you'll find your answer.
Good, because I know once I solve these two multiplication problems, I have to add them together. Well, how do I know that I'm not going to be adding anything first? What do I need to put in my equation to show that I'm not going to be adding anything first? Michaela, parentheses. Where are the parentheses going to go, Michaela?
At the beginning of the first line and the end of the 20.
Okay, is that it?
And now we're going to put 1 by the first, and then the other one by the
Good. So once I've got my equation, I'm multiplying my smaller factor by each piece of expanded form, and then I'm going to add those answers together. I need to put the parentheses around each multiplication problem to show that I have to do that first. Okay, is there anything else I need to do, or am I ready to solve? Is there anything else I need to do, or am I ready to solve? Smith?
You are ready to solve.
I'm ready to solve. So I'm going to go ahead and put a caret underneath my 10s, an arrow underneath my plus sign because I know I have to bring that down, and a caret under my 1s. Class, 3 times 20 is what?
60.
60.
60. I'm going to bring down my plus sign. 3 times 4 is what?
12.
12.
12.
Now, I know because I brought down my plus sign, I have to add these together. I don't have room for a caret, otherwise I would put a caret. But I can put it to the side. 60 plus 12 is what?
72.
Zari?
72.
72. So that means 3 times 24 is what, class?
72.
72.
72. Yes, Kingston.
You kind of did this question on example 1, but it was
Exactly, but that was in a real world problem. This is just regular. But did it still help you to have all that practice? Yeah. Okay, so let's go ahead and look at the guided practice. So the directions for numbers 1 and 2 say use the distributive property to multiply. Draw an area model. So I need everybody to super quickly get out a couple sheets of paper. Super quick. What is the first thing we should always do when we are showing work on a separate sheet of paper? Before we even get to the math part, what should we do first? Cullen?
Rewrite the problem.
We need to rewrite the equation on our separate sheet of paper so that we don't forget it. and make a silly mistake and start solving some other problem. Okay, so before we get to the area model, let's go ahead and solve this using the distributive property. Let's see. Put all the sticks back in. Victoria, you're going to help me with number 1. When we have distributive property, what do we need to do first?
We need to break down 12.
Always we break down 12 no matter what the problem is?
We need to break down the bigger number.
Good. We break down the larger factor. Don't tell me bigger number, tell me the larger factor. So, if we break down our larger factor, we're breaking down 12. How are we breaking down 12? What is it going to look like? 10 plus 2. Okay, now we need to set up our equation, right? What is our equation going to look like? We're going to take our smaller factor, and what are we going to do with that smaller factor? So we're going to multiply our smaller factor by each piece of the decomposed larger number. So we start with the tens place. Good. So 9 times 10. What next?
Plus 9 times
Our smaller factor multiplied by the ones in our decomposed number. Okay, now what? Are we done writing our equation? No, because we need to add what to this equation so that we know which parts to do first. Okay, where does the parentheses go? You can tell me on the outside of this part and this part.
outside of
Okay, and what you can tell me quickly. What am I going to put in parentheses? 9 times 10 and 9 times 2. I'm going to put my parentheses around each multiplication problem. Okay, is there anything else I need to add to my equation? No, I'm ready to solve. So I'm going to put a caret underneath each multiplication problem and an arrow underneath the plus sign because a caret tells me, hey, solve this. And the plus sign tells me bring that down. Okay, Victoria, 9 times 10. Bring down our plus sign. 9 times 2. What? 18. Now we need a caret so that we solve that. Uh-oh, Victoria, are we going to be able to solve this side to side? No, why? What are we going to have to do in this addition problem? We're going to have to regroup. So let's set it up sideways, just over to the side. Up and down, yes, that's what I meant. Victoria, 0 plus 8. 9 plus 1. Which means 90 plus 18 is 108, which means 12 times 9 is 108. Now, yes, that is a basic fact, but is it helpful to just put the answer to the basic fact when we're trying to learn this process? Not really. So even if you do come across basic facts, make sure you're still working them out. Okay, now this says to do area models. This is the only one we're going to do area models for because it's already there, because I want you to work on this. So we've already got our area model pretty much set up. Class, 9 times 10.
90.
Class, 9 times 2.
18.
18.
Class, 90 plus 18 equals
108.
108, which means that 12 times 9 is
108.
108. Okay, now number 2, we're going to use this space to do our distributive property. So, we have 22 times 6. Zari, what do we need to do first?
Write down the equation.
Well,
again on your separate
but
sheet of
before
paper.
we can even write down the equation, we have to figure out what? In number 1, before we even did the equation, what did we find?
What we were doing in expanded form.
So we were looking for we were decomposing which factor?
Our larger factor.
The larger factor into expanded form. So that means we're taking which factor, Zari?
22.
And in expanded form, 22 looks like what?
20 plus 2.
20 plus 2. Okay, now we're ready to set up our equation. What is our equation going to look like?
We're going to write our 22 times 6 again on our separate sheet of paper.
Well, we're going to solve this one here because we have room here. We're not going to do area models. But the rest of them you will do on your separate sheet of paper. We'll do number 3 together so you can see exactly what I mean. Okay, Zari, so what do? Now we need to set up our equation. We're going to do it on our math book.
You're going to do 6 times 20.
6 times 20. And I put that in parentheses because I know I have to do the multiplication first. What comes next?
2 times 6.
Well, what comes even before that? When we're writing an equation, we have 6 times 20 in parentheses.
Then
we
you
have
would write your plus sign.
a plus sign because we know we're writing the answers. And then what do I put in my other set of parentheses, Ari?
You would write 2 times 6.
So let's put it the same way. So in our first one, we had our smaller factor first. So let's do that again.
6 times 2.
Good. So we're trying to find the product for our 10s and the products for our 1s. Okay, let's draw a caret underneath each multiplication problem and an arrow underneath our plus sign to tell us to bring it down. Zari, 6 times 20 is what?
$120.
120. Bring down our plus sign. 6 times 2 is what?
12.
12. Now we draw a caret to show that we solve. Zari, are we going to have to do any regrouping here?
No.
No. So 120 plus 12 is?
137.
137.
132.
132, which means that 22 times 6 equals what, Zari?
132.
132. Okay, we're going to do number 3 and then maybe number 4 if we have time together. So, actually, let's take a quick vote. These are your options. I can tell Miss Shelton to send you back right at 11:30. I'm sorry, 11, so that you have 30 minutes to work on independent practice between Spanish and lunch. Or we can do the independent practice tomorrow, and I'll do two independent practice problems. We'll do that as guided practice, and then you'll take math class tomorrow to do the independent practice. It is your choice. So everybody, heads down. Does everybody understand the choices? Does anybody need me to explain the choices again? Kingston, okay, sorry. One more time. Your choices are, we do a practice, guided practice, a practice, independent practice now, and then you come back from Spanish early and do the independent practice then. Or we stop where we are now, go ahead and move on to our Wonder Quiz, and then do the independent practice during math class tomorrow. Does everybody understand your choices? Okay. Everybody heads down. If I see you peeking, I will not count your vote. Cover your eyes with your arm. Okay. If you want to do the independent practice today between Spanish and lunch, raise your hand. Hands down. If you want to do the independent practice tomorrow, raise your hand. Hands down. Heads up. Okay, we'll do the independent practice tomorrow. You will still have some homework tonight, though. Okay. So what we'll do now is go ahead and close your books. Do not lose these pieces of paper. Otherwise, you'll be doing it during recess. Close your books, put them away. Everybody get out one sheet of clean paper.